Welcome back to 3D Decode. In today's video, we'll dive into minimum flow protection for pumps and how it ties into the cause and effect shutdown matrix. We'll cover the theory, control strategies, C&E philosophy, calculations, and finish with an interview-style Q&A and practical exercise. Learning. Theory. Why minimum flow protection? Centrifugal pumps can overheat, vibrate, and even cavitate at very low flow. The fix? Always guarantee flow is above the minimum safe limit, Qmin, by recycling flow from the discharge back to suction or to a tank. Two standard strategies. A. Constant recycle, orifice or PCV, fixed. Simple and robust, wastes some energy at normal load. Used when Qmin is small compared to duty and energy penalty is acceptable. B. Modulating recycle, control valve with flow transmitter. FCV opens only when needed, such as during low load, start or stop. More efficient, but adds complexity. C&E controls philosophy, what must happen. When low flow is detected by FT or DP across the pump, open the minimum flow valve, fail open preferred, start standby pump if it's a duplex, and raise an alarm. If extreme low flow persists for a time delay, trip the pump or auto transfer to the standby. Sequences: start, pre-open recycle, then close as flow stabilizes. Stop or trip, command recycle open to dump energy and avoid reverse flow surges. Typical set points and instrumentation: FT pump D, discharge flow, LAL at Qmin plus margin, XV min, minimum flow valve, fail open, fast acting, TT casing, TT seal, optional, overshoot protection. Timer, low flow delay before trip, usually 10 to 30 seconds. Quick calculation, worked example. Goal: size a minimum flow device for Qmin, given that pump B equals 100 liquid brewer, Qmin equals 30%, 30 microg, fluid SG equals 0.80, ear 800 kilogram mercury, delta P across recycle 5 bar. Option 1, control valve CVQ equals 0.85, aid CV SG. So CV equals Q, make Q 5 hence delta GS, 30-30, 0.865 chemst 5.8, 13.9. Pick CV 20, so valve runs 50 to 70% open at Qmin. Option 2, fixed orifice Q equals CD of A 2 delta proliferator. CD 0.62, Q equals 0.03 milliliter delta P equals 10 P A3 equals 800. Area A 3.8 centimeters, diameter 22 millimeters. Always verify against actual delta P including line losses. Pick next standard size above this value. Rule of thumb: Qmin 25 to 35% of P unless vendor specifies otherwise. Always use vendor data if available. Mini quiz, answer in comments. 1. Name 2 reasons pumps need minimum flow protection. 2. Which strategy is more energy efficient, constant or modulating recycle, and why? 3. What fail action should the minimum flow valve have? 4. If SG drops from 1.0 to 0.7, does required CV go up or down? 5. Give one C&E action you'd add after low flow LAL. Practical task: sketch a PNID, pump, discharge, check block, plant line, recycle. Takeoff, XV min, fail open, return to tank suction. Add FT, LTTT, and valve fail position. C&E row example: cause, pump discharge flow LAL tense. Effects: open XV min, alarm, auto start standby pump. If persists LLL, trip running pump and log the event. Sizing check: use formulas to compute CV or orifice diameter for your duty. Pick the next standard size and record expected valve opening at Qmin. Interview Q&A: constant versus modulating recycle. When do you choose each? A. Constant is used for small Qmin and simple services. Modulating is used when energy loss matters or process conditions vary widely. What happens if the min flow valve fails closed during start? A. Immediate risk of low flow operation, heat rise, vibration, and seal bearing damage. That's why fail open is preferred. How do you detect low flow if there's no FT? Use DP across an orifice, motor power trends, or discharge suction glow P changes. Q. Why add a timer before trip on low flow? A. To avoid nuisance trips during short transients, but still protect equipment if the condition persists. Where should recycle return, suction or tank? A. Prefer return to tank or receiver to dissipate heat and avoid recirculating hot liquid into the suction eye. And that wraps up our session on pump minimum flow protection and how it ties into the cause and effect shutdown matrix. Don't forget to answer the quiz in the comments. And if this helped, like, share, and subscribe to 3D Decode for more deep dive engineering tutorials. See you in the next video.